We will take a look at DMVPN and support for IP version 6. We will talk about the interoperability between the versions of IP in DMVPN, and we will also talk about DMVPN routing when configuring our tunnels for IP version 6. DMVPN is fully supported for IP version 6, both inside and outside of the cloud. What I'm trying to say here is that you can use IP version 6 as your underlying DMVPN transport, plus you can also use IP version 6 on the protected subnets, on the subnets that you want to communicate over DMVPN. And the reason for it is, as we know, based on the fact that DMVPN works by using a GRE protocol for encapsulation, where GRE itself is a multi-protocol tunneling technique that allows you not only to carry IP version 4, but also IP version 6 and possibly other packet types. So this is what eventually is going to allow us to not only carry IP version 4, but also IP version 6 information. Okay, so the most important thing you will have to remember about when you are trying to use DMVPN to support IP version 6 is going to be to distinguish between the transport and the protected information. Now, in case of the underlying transport, which is what type of IP we are going to use to build our GRE tunnels, this is something that is going to be eventually controlled by the tunnel mode GRE multipoint command with or without the IP version 6 keyword. So when you say tunnel mode GRE multipoint IPv6, this means that you want to use IP version 6 as your transport. When you simply say tunnel mode GRE multipoint without IPv6, this means that you want to build a version 4 GRE tunnel. So if we were to take a look at this on a simple example, let's say that we have an IP packet with a payload. So this is a packet that is seen before DMVPN encapsulation. Well, obviously, after applying our DMVPN services, the structure of this packet is going to change. We will see a new IP header. Then we will see the GRE header for encapsulation, and finally the original packet is going to follow. IP and the payload. The payload here, it also contains the upper layer information. I just simplified this drawing. Okay, so the new IP header is exactly what is going to be controlled with our tunnel mode command. Now the content of the packet, of the GRE packet, so the GRE packet payload, which is going to be our original packet, this IP header, this is what is going to be controlled with the IP address configured on the tunnel interface. So assuming that you want to protect IP version 4 packets, you will have to configure an IP version 4 address on the tunnel. If you want to protect version 6 packets, you will have to configure the tunnel with a version 6 address. And as a side note here for version 6 addresses, whenever you will put version 6 address on the tunnel, you will also have to hard code a link local address. You want to make sure that those addresses are unique across the entire DMVPN cloud. And this is based on the fact that all addresses will be part of the same subnet on a per cloud basis. And since the regular version 6 control plane mechanisms cannot work before the GRE tunnels are established, it is going to be actually possible to see duplicate addresses on the tunnels, link local addresses on the tunnels, and this is why you should hard code them in the first place. And just to quickly visualize this concept, if we were to take a look at a simple DMVPN setup with a hub and a spoke, assuming that our spoke is connected to a version 6 subnet, this device is also configured with a tunnel interface. Well, obviously, assuming that you want to protect this version 6 subnet, the type of the address configured on the GRE interface would be also version 6. Because if you were to put a version 4 IP address on the MGRE tunnel, Obviously, the other devices that are to communicate with the subnet, they would see the next hop being set to version 4 IP address for a version 6 prefix. So this is something that is not going to work, because obviously to find the version 4, the next hop, this information is not stored inside of a version 6 routing table. So whenever you will want to protect version 6 subnets, you will also have to configure a version 6 address on the tunnel. If you want to protect version 4, you want to use version 4 on the tunnel. You cannot mix these two. It doesn't make any sense to do this. Probably the most important element to configure version 6 of DMVPN is going to be the mappings that you will have to put for NHRP. So depending on the actual type of a setup you want to have, like to tunnel version 4 packets inside of version 6 DMVPN, or maybe do the opposite, or maybe just tunnel version 6 packets inside of version 6 DMVPN, you will have to configure different types of NHRP mappings. So those mappings can be all version 4, they can be all version 6, or you can see mixed mappings, like when you want to use one type of IP for transport and another type of IP for your payload. So it is possible to see a mapping like that. For example, like what is shown here, you can map version 6 address to version 4, but this is not something that is talking about routing. It is just for NHRP. And now, as a general rule, in most cases when you will deploy version 4 DMVPN, you will protect version 4 packets, so all mappings will be version 4. In case when you want to deploy version 6 in version 6 DMVPN, all mappings will be version 6. Now, probably the easiest way to figure out what addresses you should put when you do the mixed mode config, so version 4 in version 6 or vice versa, is going to be to say IP version 6 NHRP question mark, and simply rely on the context-sensitive help to tell you what address is needed to build a given type of the mapping. You don't have to worry about link local addresses. They will be mapped automatically. So NHRP mappings that you will build for version 6 of IP, it is going to be for unicast addresses, like global, site local addresses. Link local addresses will be mapped for the NHRP communication. This is going to happen dynamically. And to finish our discussion on IPv6 DMVPN, just a couple words about routing. So this is going to apply to the design in which you are using a DMVPN to protect version 6 subnets, version 6 traffic, like when you deploy IP version 6 addresses on the tunnel interfaces. In this case, you will also have to enable a version 6 routing protocol, like OSPF-v3, EHRP version 6, or BGP, with multi-protocol extensions. And then for configuration, well, you will obviously have to start with enabling a version 6 unicast routing, and then the remaining syntax is going to depend on the actual protocol type. There are going to be no changes from the DMVPN behavior, phase 1, phase 2, phase 3 behavior. This stuff is going to be exactly the same as what we saw for IP version 4.